Okay, so I go for an example involving finding the expectation and the variance from a probability generating function. So we've got a fair coin is tossed 3 times and the number of tails x is noted. And we want to first of all find the probability generating function of x. With these questions you need to think about, is it a known distribution? And if it is, then you can use the standard results, so you don't have to keep proving standard results. So for this one, if x is the number of heads, and we've got a fixed number of trials, fixed probability of success, independent outcomes, and so it's binomial distribution. Standard results are given to you in a formula book, I'm pretty sure, but for the binomial, the probability generating function of x is 1 minus p plus pt to the power n. So we've looked at all those. So probability generating function of x is equal to 1 minus p, which is a half, plus pt to the power n, which is 3. So you can pretty much write that down. And then we can look at finding the expectation of x. And the expectation of x is equal to the probability function differentiated with 1 fed through it. So I need to differentiate this. We will actually, in maths, look at a quicker way of differentiating brackets to powers, but for now we need to expand this. So if I pull out a half, from that bracket, and then you can split a power across the multiplication, so that gives me 1/8 1 plus t cubed, and then you can expand 1 plus t cubed with a binomial expansion. So if you think about Pascal's triangle, you're on the 1, 3, 3, 1 row. So it's the first part to the highest power. So it's 1 cubed plus 3 lots of 1 squared times t plus 3 lots of 1 times t squared plus t cubed. Or you can do that in a table or write down a bit more if you need to. Differentiating that, I can just leave that 8 on the outside if you think about it. You think about that if you need to. I'll come into that side of the board. And so differentiating so number disappears, 3t differentiates to 3, 3t squared goes to 6t, and then t cubed goes to 3t squared. And so the expectation of x is equal to the probability generating function. It's 1 fed 3, so it's an 8, and then 3 plus 6 plus 3 gives me 12. So I get 12 over 8, which is equal to 3 over 2 for the expectation. If you think about this, we've got a fair coin tossed 3 times. I'll just take that off so I can write that. If you think about the shape of your binomial distribution, if p is a half, possible outcomes are 0, 1, 2, 3. If p is a half, then you get a symmetrical distribution for binomial. And so the mean will be in the middle of your distribution at 1.5. You can use that in questions if you know you've got a symmetrical distribution to some extent. So just something to think about. If p is less than a half, then you're more likely to get lower numbers, so you'll get a skew out this way, and if p is bigger than a half, it'll come around that way for your binomial. Right, then we can find variance of x. So part 3, find variance of x. There's no quick way of doing this. And if you remember the formula for the variance, I don't think you're given this, so we can sort all this out before your exam next year anyway, but so you just differentiate probability function again, feed 1 through, and then it's plus the expectation minus the expectation squared, which looks like that. It's a formula. So differentiating again, if I just put the first derivative down again. So yeah, differentiating again. Again, that 8th can just sit there. 3 disappears, 6t goes to 6, and then 3t squared will differentiate to 6t. And so we get 12 over 8, which is 3 over 2 again. The second derivative of 1 fed through. And so the variance of x is equal to 3 over 2 plus 3 over 2 minus, sorry, there's lots of 3 over 2's in this, but I think it's quite straightforward, minus 3 over 2 squared. So I get 3 over 2 plus 3 over 2, 6 over 2, which is 3, minus 9 over 4, which gives me 3/4. And then if you want the standard deviation, you can square root the variance, just to remind you. And so the standard deviation for this one would be √3 over 2.